Welcome once again, dear students. This is our fourth lecture, and it's still a continuation of our review of derivatives. But for this session, we will focus on derivatives of trigonometric functions. And for this session, I have set the following objectives. Number one, that you will be able to differentiate trigonometric functions. And the number two, that you'll be able to use trigonometric identities to simplify given functions. Now, before we go into the derivative formulas for trigonometric functions, okay, let's first again define a transcendental function or describe a transcendental function, which in the past we have dealt with algebraic functions. Okay? So when is it transcendental? A function that is not algebraic or that which cannot be expressed in terms of algebra is called transcendental function. And the examples of transcendental functions are your trigonometric functions and the inverse trigonometric functions, your exponential functions, and logarithmic functions. Take note that they are inverses of each other. Okay, your trigo and inverse trigo, expo, and logarithmic are inverses of each other. Okay, but this session will focus on trigonometric functions only. But prior to giving you the derivative formulas, let's first recall trigonometric identities. Okay, a trigonometric identity is a relationship among the trigonometric functions. And the following are the trigonometric identities which are result or immediate consequences of the definition of the trigonometric functions. Or sometimes they call this the reciprocal identities. For instance, your cosecant theta is the reciprocal of sine theta. Okay, so cosecant theta is cosecant theta is 1 over sine theta. Your secant theta is the reciprocal of your cosine theta. Secant theta is equal to 1 over cosine. Your tangent theta, or cotangent rather, is the reciprocal of tangent. Okay, so these are the reciprocal identities. Okay, those are the reciprocal identities. And you know also that tangent theta is the ratio of sine to cosine. Okay, so tan theta, tangent theta is equal to sine theta over cosine theta. And cotangent theta, since tangent and cotangent are inverses of each other, then you simply have to swap the places of the numerator and denominator. So your cotangent theta must be cosine over sine. Okay, so these are the basic trigonometric identities. Now, we also have what we call Pythagorean identities. Okay, this came from your Pythagorean relationship, or the relation between and among the sides of a right triangle. Okay, this in fact can be derived from the unit circle. So if you draw the unit circle, okay, a unit circle is a circle whose center is at the point of origin and whose radius is 1. You will be able to show this relationship between the square of sine and the square of cosine. Okay, so this is the Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. And the two others are direct consequences, or should I say, are obtained or could be obtained rather from the previous. Okay, for instance, to come up with tan squared theta, we can divide every term of the first identity by cosine squared. Okay, so let me show that. So from your sine squared theta plus cosine squared theta equal to 1, if we divide every term by cosine squared theta plus cosine squared theta equal to 1 over cosine squared theta, what do we get? Okay, you know that the ratio sine theta over cosine theta is tangent theta. However, this is sine squared. So, this must be equal to tangent squared theta plus cosine squared theta over cosine squared theta is equal to 1. Equal to, okay, 1 over cosine from our previous set of identities is secant. However, this is 1 over cosine squared. Therefore, this is equal to secant squared theta. So that was how the second identity was obtained. In like manner, we can also derive the third, from the first. So just like what we did in the first, or in the previous, I should say, divide this time the whole equation by, with this time divide the whole equation by sine squared. Okay, so from here, sine squared theta plus cosine squared theta equal to 1. We divide every term by sine squared theta. Okay. We'll end up with sine squared theta over sine squared theta is equal to 1 plus cosine squared theta over sine squared theta is cotangent squared theta equal to 1 over sine squared theta is equal to cosecant squared theta. So that was how the third identity was obtained. Okay? So this is the most important identity among the three identities classified under this category, because from here you could derive the two others. Okay, now we move on to the next. We have the odd and even functions. Sine of negative theta, okay, sine of a negative angle is equal to the negative of sine of the positive of that angle. And cosine of a negative angle is equal to cosine of theta. We can verify with one example. For instance, sine of negative 30. That negative 30 degrees is the same as coterminal with 330 degrees, yes? Okay, so sine of negative it's coterminal, yes, with 330 degrees, so negative 1/2. So it's negative of sine of 30 degrees is 1/2. Equal, they are equal. Negative 1/2 equal to negative 1/2. We now proceed to the next set of identities. We have your sum and difference identities. So your sum and difference identities for sine of x plus y is equal to sine x cosine y plus cosine x sine y. For sine of x minus y, okay, sine x cosine y minus cosine x sine y. For this time cosine of two angles, cosine of x plus y is equal to cosine x cosine y minus sine x sine y. For cosine of x minus y, it's equal to cosine x cosine y plus sine x sine y. For tangent x plus y, it's equal to tangent x plus tangent y all over, okay, all over 1 minus tangent x tangent y. For tangent x minus y, we have tangent x minus tangent y all over 1 plus tangent x tangent y. Okay, so these are your sum and difference. Next, we have the double angle formulas. Okay, the double angle formulas. For sine of 2x, we have 2 sine x cosine x. Cosine of 2x is equal to cosine squared x minus sine squared x. Okay? Or cosine of 2x also is equal to 2 cosine squared x minus 1, or cosine of 2x could also be equal to 1 minus 2 sine squared x. Now you can in fact derive this and this from the previous. Okay, so going back to your Pythagorean identity, from your Pythagorean identity, remember sine squared theta plus cosine squared theta is equal to 1. Express one function in terms of the other. So for example, sine squared theta is equal to 1 minus cosine squared theta. So looking at this, okay, looking at the first, okay, for cosine 2x, cosine 2x is equal to cosine squared minus sine squared x. So I could replace sine squared x with this now. Okay, so I could replace cosine squared x or sine squared x with 1 minus cosine squared in terms of x. So let's be consistent for a while. Let me change this into sine x. So sine squared x plus cosine squared x equal to 1. Okay, so sine squared x is equal to 1, equals, is equal to 1 minus plus cosine, 1 minus cosine squared x. Okay, so from here, and from this, we will now replace sine squared x with what we got from here. Okay, so we are going to replace it. Okay, so let me just copy. Cosine 2x is equal to cosine squared x minus sine squared x. But replacing now, okay, sine squared x with the expression that we obtained from the previous, okay, replace it by this, we'll end up with cosine 2x is equal to cosine squared x minus, and close it in a pair of parentheses, 1 minus cosine squared x. And further simplification, what do we get? Negative. Okay, the negative of negative cosine squared will be positive cosine squared x. Yes, combine it to cosine squared x, then we shall have 2. Yes. Or let me just present it then, or write it then just the same. Cosine squared x minus 1 plus cosine squared x. So combining these two, combining this with this, will end up with 2 cosine squared x minus 1, which is in fact the pair. Okay? So, you don't have in fact to memorize this. If you know this, you can derive the two other identities for cosine 2x. Okay? Now, moving on to your half angle formulas. This time we have cosine squared and cosine squared x equal to 1 plus cosine 2x. In fact, you can derive this from the previous, okay, from here. Okay, you can derive this from here. Okay, your half angle formula, since we don't have space, I will not show that anymore. Cosine squared x is equal to 1 plus, you try it, okay? Show how the half angle formulas are derived. And in like manner, sine squared x, which is equal to 1 minus cosine 2x over 2. Okay? Or if we want to simplify further, then extract the square root of both sides, because this is in the second power. Okay, this is in the second degree. Now moving on to the next. Okay, so the last of our set of identities are the product formulas. So for sine x cosine y, it is equal to 1/2 times the quantity sine x plus y plus sine of x minus y. Okay, for cosine x times cosine y, it is equal to 1/2 of the quantity cosine of x plus y plus the cosine of x minus y. Last, for sine x sine y, we have 1/2 of cosine of x minus y minus the cosine of x plus y. So please do not forget your identities, because when I will be asking you to express answers in simplest form, you will be needing the identities. And sometimes also the problem would require you to prove whether a given expression is the derivative of a given function. But you have to have a good grasp of your trigonometric identities. So it should be within reach. Okay? So now we proceed to derivatives of trigonometric functions. So your basic trigonometric functions are your sine, cosine, and tangent. Okay, again, how do we call these three? The three others are the reciprocal ratios or reciprocal functions. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Okay, let's move on to derivatives then. Number 1, okay, the derivative of sine x is equal to cosine x. Next, the derivative of cosine x is equal to negative, okay, negative sine x. Next, derivative of tangent x is equal to secant squared x. Now, we can prove this. We can show that the derivative of tangent is really equal to secant squared. Okay? How? So, express first tangent x as the quotient, or by definition, tangent x is equal to sine x over cosine x. Yes? Okay, let's show. Let's prove. Let y be equal to tangent x. But by definition, tangent x is sine x over cosine x. Okay, look at the form. The form is the form is a quotient, UV. Okay, so it's in the form of a quotient. Therefore, to get y prime, we have to apply the quotient rule. So y prime is equal to, remember our shortcut, u dv, or v du rather, minus u dv. Okay, so from our previous discussions or previous lesson on derivative of a quotient, v du minus u dv, or the denominator times derivative of the numerator minus numerator times derivative of the denominator. So let's do that. V is cosine x. Du, what did we say about derivative of sine x? Derivative of sine x is, from here, derivative of sine x is cosine x. So I have to write here cosine x minus, okay, u dv minus u, let me use another color so that it will still be visible if I continue on this side. U dv is sine x times derivative of the denominator. Derivative of cosine is negative sine x. So times negative, okay, times negative sine of x. All over, okay, all over the square of the denominator, cosine squared x. Okay, let's simplify further. What will this give us? Okay, let's find out what will this be. Y prime is equal to cosine x times cosine x is cosine squared x minus sine x times negative sine x. Take note of the sign. Okay, take note of the sign. We have here negative, negative, so this will be plus sine, okay, sine squared x all over cosine squared x. Okay? Now, I want you to pay attention to the numerator. What can you say about the numerator? Is there any way by which we can simplify the numerator? Cosine squared x plus sine squared x. Again, cosine squared x plus sine squared x. From your, okay, from your Pythagorean identity. Let's check on the Pythagorean identity once again. Okay, let's go back there. You see this, your Pythagorean identity. Sine squared x plus cosine squared x is equal to 1. Okay? So it's equal to 1. So our numerator is 1 over cosine squared x. But what is 1 over cosine? What trigonometric function is 1 over cosine? It's secant. Therefore, y prime is equal to, but this is 1 over cosine squared x. In fact, you can break this down as 1 over cosine x times 1 over cosine x, making it secant times secant. Okay? So, secant squared x. Okay, so that's how the derivative of yan. Okay? That's how this was obtained. Okay? So, the derivative of your tangent x is equal to secant squared x. Next, the derivative, okay, the derivative of cosecant x is equal to negative cosecant x cotangent x. Okay, negative cosecant x cotangent x. Okay, you can also show, okay, or prove or verify the derivative of cosecant x is equal to negative cosecant, cosecant x cotangent x by expressing cosecant x in terms of sine. Okay, so it will be y. So let's have this one then. Okay, so y is equal to cosecant is 1 over sine x. 1 over sine x. Okay, cosecant x is 1 over sine x. So taking y prime, okay, and treating this as a quotient, then y prime is equal to numerator or denominator rather, sine x times derivative of the numerator, which is derivative of a constant is 0, minus, okay, the numerator 1 times derivative of the denominator, derivative of sine is cosine, okay, cosine x, all over cosine x all over the square of the denominator over sine squared x. So when simplified, what is y prime equal to? This will be eliminated because it will be 0. So negative, look, cosine x over sine squared x. But in fact, I could break this apart into two factors as negative 1 over sine x times cosine x over sine x. Okay? Okay. Okay, 1 over sine x times cosine x over sine x. Okay? But what is this fraction? Okay, 1 over sine x once again is your y prime equal to negative cosecant x, and cosine x over sine x is what function? It's cotangent x. Okay, negative cosecant x cotangent x, and that's it. See that? Sorry. See this? Compare it. Okay, so that's how we could verify or prove that the derivative of cosecant x is really negative cosecant x cotangent x. Okay, so you can do the same for secant x. Derivative of secant x is secant x tangent x, and derivative of cotangent x is negative cosecant squared x. And its proof would be similar to this. Okay? So, if you know the derivative of sine and you know the derivative of cosine, then do not worry because you can derive or you can, okay, yes, on your own, find the derivative of tangent x, cosecant x, secant x, and cotangent x. Okay, because you know very well anyway your quotient rule. Now we proceed to the next. If the argument, if the angle, or if u, okay, if u is a differentiable function of x, then derivative of sine u with respect to x is equal to cosine u du. Derivative of u with respect to x. Okay? Cosine u du. Derivative of u with respect to x. Next, derivative with respect to x of cosine u, where u is still differentiable, is equal to, again, do not forget, negative sine u times du. The derivative of u with respect to x. Okay? Next, for tangent u, its derivative is secant squared u times du. For cotangent u, its derivative is the negative of cosecant squared u times du. For secant u, we have secant u tangent u times du. For cosecant u, the negative of cosecant u o tangent u times du. Okay, now let's move on to the next slide. Now, applications of the formula. Okay, let's solve the following. Find the derivative of the following or differentiate the following. Now, let's look into number 1. Okay, looking at number 1. Okay, the given is f of x is equal to x cubed plus sine x. Okay, so here we have the sum of x cubed and sine x. Okay, from your sum and difference rule, f prime of x is simply derivative of the first plus derivative of the second. So, f prime of x is simply, differentiate x cubed. What will it be? From power rule, it's 3x squared. Plus, now differentiate sine x. Derivative of sine x from our previous slides is cosine x. Okay, so this is the answer. Okay, so as simple as that. F prime of x is equal to 3x squared plus cosine x. Now we proceed to the next problem. Now, how about number 2? Now let's compare it to number 1. Now going back to number 1, what is the operation? What's the operation rather between the two? It's addition. Okay, so how did we get the derivative? Was simply differentiated the first and then the derivative of the second. Now, going back. Okay, the function this time is x cubed sine x. X cubed sine x. Okay, so this is a product, of two functions. And what are they? X cubed and sine x. Okay, so what rule are we going to apply for number 2? We have to apply product rule. Okay, we have to apply product rule. So what did we say about the product rule? If the function takes the form u times v, where u and v are differentiable functions, then y prime, what did we say? Y prime is equal to u dv plus v du. Okay, let's apply that here. What will f prime of x be? Okay, so here, your u is x squared. And your v is sine x. Okay, so your v is sine x. So applying this rule, u dv plus v du, then f prime of x is equal to u x squared or x cubed rather dv, derivative of sine x. What is the derivative of sine x? Derivative of sine x is cosine x. Okay, so we're done with u dv. So we're done with u dv. We now proceed to plus v du. Plus v du. So plus v sine x times du, derivative of this. Okay, derivative of x cubed, which is 3x squared. Okay, or you may express it in factored form as common factor is x squared times x cosine x plus 3 sine x. Okay? X squared times x cosine x plus 3 sine x. This is our final answer. Okay, so this is now final answer. So derivative of x cubed sine x is equal to x squared times x cosine x plus 3 sine x. Now we move on to number 3. Okay, so for number 3, look at the form. Okay, we have cosine of not x but x cubed. Okay, cosine of x cubed, which means that this is of the form, okay, this is of the form cosine u. Okay, cosine u. And what did we say about derivative of cosine u? It's if y is equal to cosine u, then what is y prime? Y prime is equal to negative of sine u times du. Okay, so in here, our u is, x cubed. Our u is x cubed. So this one takes the form cosine u. So the function takes the form cosine u. Cosine u. So therefore, its derivative now, take f prime of x is equal to, here, what did we say? Derivative of cosine u is equal to negative sine u du. So again, negative sine u du. Okay, so f prime of x rather is negative sine of x cubed times derivative of x cubed, which is 3x squared. Or f prime of x is equal to negative 3x squared sine of x cubed. Okay? Okay, so this is our answer. Okay, so f prime of x is equal to negative 3x squared sine x cubed. Moving on to number 4. Okay, this time, okay, looking at number 4. F of x is equal to cosine x over sine x. Okay, cosine x over sine x. Now, looking at the form, this is a quotient. Okay, this is a quotient wherein your numerator is cosine x and your denominator is, okay, your denominator is 1 minus sine x. So here we have a quotient. So what are we going to apply then? We have to apply, okay, so for this problem we have to apply the quotient rule. Quotient rule. Okay, apply the quotient rule. Okay, remember the quotient rule, if the function takes the form u over v, then y prime is equal to v times du minus u times dv all over v squared. Okay? So your quotient rule. So now let's proceed then. F prime of x is equal to, okay, go back, v du minus u dv. V du minus u dv. Okay, this is our v. Okay, so I have to write now v. 1 minus sine x times du. Okay, derivative of this. Derivative of cosine x. What did we say about derivative of cosine x? It's negative sine x. Okay? Next, minus u dv. Okay? Minus u dv. U is cosine x. Times dv. Derivative of this. Derivative of 1 is 0 minus derivative of cosine or of sine rather is cosine. So minus cosine x all over, okay, all over 1 minus sine x squared. Okay, let's simplify further. F prime of x is equal to, when you multiply, what do you get? A negative sine x. Okay, from here, negative sine x, correct? And then negative sine x times negative sine x, what's the product? Will be plus sine squared x. Okay? Next, if I multiply this two, maybe this is 0, what will the product be? Plus cosine squared x. Correct? All over, okay, 1 minus sine x raised to 2. Now, is there any way by which we could simplify the numerator? F prime of x is equal to, now I'd like you to pay attention to the last two terms of the numerator. Again, from your identities, sine squared x plus cosine squared x is equal to, from our Pythagorean identity, okay, but sine squared x plus cosine squared x is equal to 1. So, negative sine x plus 1 all over 1 minus sine x squared. So, we can further simplify this because if you write this in this manner, 1 minus sine x all over 1 minus sine x squared, we could cancel out, yes? We could, okay, simplify this as, this will cancel out and this becomes 1. Okay, so finally, the simplest answer would be 1 over 1 minus sine x. Okay, so this is our final answer. So let me enclose it in a box. Okay, so this is our final answer. So your f prime of x is equal to 1 over sine x. Moving on to number 5. Now let's proceed to problem number 5. So for problem number 5, this time, look at the given. Tangent cube, okay, of the square root of x. Tangent cube of the square root of x. Okay, tangent cube of the square root of x. So we have here tangent raised to the third power. We can in fact rewrite this as, we can rewrite the given as tangent of x raised to 1/2 raised to the third power. Okay? Tangent of x raised to 1/2 raised to the third power. Okay? So take note that this is of the form, okay, this takes the form u raised to n. Your generalized, your GPR, power rule. Okay? The generalized power rule, or your GPR. Okay? Your GPR, generalized power rule. So if this is u to the n, then what is our u? The u must be this. The u is tangent of x raised to 1/2. Okay, so if we make use of the generalized power rule, then what will the derivative be? So f prime of x is equal to, so in fact this takes the form u cube. Okay, it's u cube, u raised to the third power, so u to the n. And what did we say about derivative of u to the n? Y prime is equal to n u raised to, subtract 1 from the exponent, times the derivative of u. Okay? So this is your generalized power rule. The generalized power rule. Okay? If y of the function could be expressed into u raised to n, u is a function, okay, in x, or a differentiable function, then y prime is equal to n u raised to n minus 1 times du. So let's apply that here. Applying the generalized power rule here, the exponent 3 times u, which is tangent of x raised to 1/2 raised to, subtract 1 from the exponent, which is 3 minus 1, 2, times du. However, our u itself takes the form tan u. Okay, look. Our u is tangent not only x, but tangent x. So this we have to apply the chain rule. Remember composition of functions? Okay, so it's not simply tan x, but tan u. And what did we say about derivative of tan u? Secant squared u times du. Okay, so times derivative of tan of x raised to 1/2 is secant squared of x raised to 1/2. Just for a minute, let's use, it's alright, x raised to 1/2 times, we also have to differentiate x raised to 1/2. Okay, from our chain rule. So here we also have to apply the chain rule. Okay, applying the chain rule. Apply the chain rule, and also if y is equal to tan u, tangent u, where u is differentiable, then y prime is equal to secant squared u times du, derivative of u. Okay, so here our u is x raised to 1/2. So we still have to differentiate x raised to 1/2. We won't stop here. Okay, so differentiating x raised to 1/2, what do we get? Times 1/2 x raised to, subtract 1 from the exponent, negative 1/2. Okay, so let's simplify further. F prime of x is equal to 3, we could combine, we could multiply 3 with 1/2. Okay, we could multiply 3 with 1/2, giving 3 halves. Okay, so 3 halves, 3 over 2. And now instead of writing the exponent outside the grouping, I could write it here. I could put here tan squared. Okay, so tangent squared, and instead of x raised to 1/2, I could write it as square root of x. So tan square root of x times secant squared square root of x. Okay, and what happens to this? What happens to this? Okay, with the negative exponent, make it positive, I have to write it in the denominator. So, all over, okay, all over the square root of x. Okay, or in fact, I could put this together, 2 and this, I can put them together. I could write it in this manner. Okay, so I could have f prime of x is equal to 3 tangent squared square root of x secant squared square root of x all over square root of x. Okay, all over the square root of x. So this is our final answer. Okay, so that's the final answer for number 5. Okay, moving on to number 6. Okay, let's proceed to number 6. Okay, now let's first examine the given. Looking at the given, particularly the first term, because there is an operation addition here, so that means there are 2 terms in the given. Okay, the first is, the given rather is y equals the quantity 2 minus x squared times cosine x plus 2x sine x. Okay, so this is one term, this is another term. However, looking into each term, okay, the terms are in fact products. Yes, so look at the first. 2 minus x squared times cosine x. And the second, 2x times sine x. So, we have to apply both sum difference and product rule. Okay, and the product rule. Okay, product rule. So let's do it now. Y prime equal to, remember your product rule once again. If the function takes the form u times v, where u and v are differentiable, then y prime is equal to u times derivative of v plus v times derivative of u. Okay, so let's focus our attention to the first term. Again, like what I said a while ago, the first term is in fact a product of 2 minus x squared and cosine x. Okay, so applying our product rule, y prime is equal to u dv, u, 2 minus x squared dv. Derivative of cosine x is negative sine x. Okay, plus v du. V is cosine x times derivative of u is 0. Why 0? Because derivative of 2, which is a constant, is 0 next. And derivative of x squared is 2x. Okay? So we're done with the first. This is only derivative of the first, okay? Please do not forget that we're on the first term still. Okay? We're not done yet with the second. So we continue. Plus. Now, looking at the second term, it also, okay, your second term also is a product between 2x and sine x. Okay? So it's a product between 2x and sine x. So here, your 2x is your u. It's not visible. Your 2x is your u, and your sine x is your v. So it's still a product. So let's get then the derivative using the product rule. U dv 2x dv, derivative of sine x is cosine x plus v du sine x times derivative of 2x is. Okay, so we're now going to simplify. So your y prime now will be equal to the quantity 2 minus x squared times sine x, negative sine x, minus, when I multiply the 2, I'll get the 2x cosine x plus 2x cosine x plus 2 sine x. We should have multiplied this with this already. Okay, let me add that in. Okay, so let's go back to the first. Y prime is equal to, multiplying this with this now, we get negative 2 sine x. And multiplying negative x squared with negative sine x, what do we get? Plus x squared sine x. Okay, combine like terms. Take note that negative 2 sine x plus 2 sine x is 0. Yes? So we have to cancel it out. Okay, so this with this is 0. Anything else? We can also cancel out this one, negative 2x cosine x with 2x cosine x. So the remaining terms are y prime is equal to Okay. X squared sine x. Okay. So, the answer is prime equal to x squared sine x. Okay. Y prime equal to x squared sine x. Now we move on to problem number 7. So for problem number 7, we have to show that y prime is equal to cosine 2x, that y prime is equal to cosine 2x from here. The derivative of this is equal to negative cosine 2x. Okay, so here you could first simplify the given. So take note that we have two quotients, yes? Okay, the first fraction is sine squared over sine squared x over 1 plus cotangent x, and the second fraction is cosine squared x over 1 plus tangent x. Or first thing that we have to do is to simplify the given. Okay, we simplify first the given. Okay, let's simplify by expressing tangent and cotangent in terms of sine and cosine. Okay, so y is equal to sine squared x over 1 plus, express cotangent in terms of sine cosine, cotangent x is equal to cosine x over sine x. Okay, plus, we do the same with the second fraction, cosine squared x all over 1 is x plus a cosine squared x all over 1 plus tangent x is sine x over cosine x. Take note that we ended up with some complex fractions here. Okay? The first is a complex fraction, is a fraction or a numerator over a complex fraction. So both are complex fractions. So let's express them into a single fraction only by first.
Ito masyadong maliit na.
Hindi. Kita naman.
Silicon.
Okay. So, sine squared x all over, combine or express the denominator into one fraction. This is equal to sine x plus cosine x all over sine x plus cosine squared x all over, express this into a single fraction also, cosine x plus sine x all over cosine x. Okay? Now, continue simplifying the given. Let's continue simplifying it. Y is equal to, take note that division is inverse multiplication. So let's express this as sine squared x times, we get the reciprocal. Okay? The reciprocal of the denominator will be sine x all over sine x plus cosine x. Now we do the same with the second. Cosine squared x all over, times rather, okay, cosine squared x times, if we get the reciprocal of the denominator, we'll end up with cosine x all over cosine x plus sine x. Okay? So your y is equal to, by multiplying, so take note that their denominators are now the same. Sin x plus cosine x plus sine x, by commutative property, they are equal. Okay? So I could express this now into one big fraction whose denominator is sine x plus cosine x. Okay? Sine x plus cosine x. And the numerator will be sine cube x plus cosine cube x. Okay, from here, we could do some factoring. Okay, so we could do some factoring. This y is equal to, do some factoring. Take note that our numerator, the numerator is, highlighter, it should be highlighter. Our numerator is a perfect cube. Okay, perfect cube. Remember your special products and factors. For x cubed plus y cubed, how do we factor out factors? How do we factor out x cubed plus y cubed? Okay, what are the factors? Take note that this could be factored as, okay, x cubed plus y cubed. I want to draw your attention here, in the top part of the screen, or on the top part of the slide. X cubed plus y cubed is equal to, okay, x plus y times the square of the first minus the product, okay, plus y squared. So if we do the same, then we could factor out then the numerator of this as, okay, sine x plus cosine x times sine squared x minus sine x cosine x plus, okay, plus cosine squared x. Okay, all over, sine x plus cosine x. Okay, and this will cancel out. Okay, so y prime then is equal to, or sorry, not y prime yet. It's just y. Y is equal to, now, from your Pythagorean identity, what is sine squared x? Okay, Sine squared x plus cosine squared x is equal to 1. Yes, 1 minus sine x cosine x. Okay, so we simplified the given into this. So we came up with a very simple form of the given, and which is y minus sine x cosine x. Now we are ready to differentiate. So y prime equal to derivative of 1 is 0 minus, okay, look at this, it's a product. UV, okay, UV, VD minus, let's enclose it in, okay, minus UV. U is sine x, UDV, rather UDV, okay, sine x, and derivative of cosine x is negative sine x, okay, UDV plus VDU. Cosine x times derivative of sine x is cosine x. Okay? Now, y prime equal to, may we disregard this anyway, it's 0. Look. Okay? Negative, negative. What will this be? This will be positive. Okay? Sine squared x. Okay, how about the second? Negative and positive will be minus. Okay, minus cosine squared x. Okay, now go back to your list of identities. Let's go back to our way. Remember this. Remember sine squared x minus cosine squared x. Now let's go back to our double angle formulas. Let's go back to that slide on double angle. Okay. Okay, look at your double angle formulas. Look at your double angle formula, particularly this. Okay. Cosine squared x minus sine squared x. Okay, so cosine squared x, let me copy from the previous. From the double angle, cosine 2x is equal to, okay, let me please have that here. May I draw your attention to the top portion so I could write it here. Okay, let me write the formula. Cosine 2x is equal to cosine squared x minus sine squared x. Okay, but what are we going to show? Look, we are to show that the derivative of the given is negative cosine 2x. So, let's rearrange the terms. We'll simply have to rearrange the terms so that we will write negative cosine squared x first plus sine squared x. If I bring out, or if I factor out negative 1, then this becomes cosine squared x minus sine squared x. But what did we say? What is this equal to in relation to this? What is it equal to? It's cosine 2x. So finally, y prime is equal to negative. Again, what is this equal to? This is in fact your cosine 2x. Okay, so this is your cosine 2x. So negative cosine 2x. Okay. So were we able to show that the derivative of the given is in fact negative cosine 2x? Yes. Okay. So derivative of the given is negative cosine 2x. I leave numbers 8, 9, and number 10 for your assignment. Okay? I will upload this PowerPoint presentation to your Lens. Okay? You log into your Lens account and download, and your answers to numbers 8, 9, and 10 should be submitted to Lens 2. Okay? Thank you very much for joining me once again in this session. Hope you learned from our fourth session. See you next meeting for derivative of inverse trigonometric functions.